There's actually 5 ways we're going to learn to solve a system of linear equations. However, in this chapter, we're going to learn 3 of them. We already learned the graphing technique, and that's pretty visual. We could see exactly where the 2 lines intersect. Well, now we're going to transition to algebra, where it's more abstract. We just have to trust our math in order to realize we're getting the right solution. So we're going to learn 2 techniques. One's called the substitution technique. The second is called the, well, there's different ways you can say it. It's either called the combination technique, the elimination technique, or the multiplication and addition technique. So it's your choice. So on a quiz, I might call it one of those 3 things. Okay, the substitution technique. The concept behind that is you can take something and replace it with something of what value? Equal value. If in your hand you have a nickel, and we take that out, we could put something in its place, and that's what? 5 pennies. And we'd have the same amount of money, 5 cents. So we substitute the nickel, 5 pennies. We got a problem. If I'm taking these 5 pennies and one of them drops, and I only put 4 cents in your hand, did I substitute properly? No. So what I'm going to do is I'm going to tape these together. I'm going to put some tape around them so they don't fall apart. So when I put them in your hand, all 5 of them reach your hand. All right, so what I'm going to do is I'm going to package these pennies together with some tape so all 5 of them end up in your hand. The analogy is when I have an equation, for example, y equals 3x plus 4, I would like you to tape it together, package it with parentheses, all right, so you don't lose any part of it. The reason being is when we substitute that into an equation, for example, 5x plus 7y, when we substitute that in, we're going to have to distribute that 7 to everything, and the best way to do that is have a parentheses. So let's go ahead and try the substitution technique. Okay, with a lot of math, there's the smart way to do it, the easy way to do it, and then there's a more difficult way to do it. And I would like you to utilize the easy way to do things. When you use the substitution technique, you should always pick the easiest variable. The easiest variable has what kind of coefficient in front of it? A 1. Or second choice would be a what kind of 1? A negative 1. So which one's the easiest to solve for? Top, bottom, x or y? The bottom, x. Oh, hey, you know what? It's already solved for x. The first step's done for us already. X in the second equation is already solved for. So what we do is we substitute this expression into the, this is the key word, into the other equation. So we're going to substitute that expression 4y plus 14 into the other equation. So here's the other equation. We're going to take x and substitute 4y plus 14. Let's go ahead and multiply that out. Let's subtract 70. You get 22y is negative 66. So y is negative 3. Once you get a concrete value, x equals a number or y equals a number, in this case y equals negative 3, you're free to substitute wherever you want. So which equation you want to substitute this into, the top or the bottom? Put negative 3 into either the top or the bottom. Which one? The bottom. So that's the easiest one. My recommendation is to write the whole thing down, 4y plus 14, and there's the y. We're going to substitute that into the y, for the y. We get negative 12 plus 14, so x is equal to 2. We need to write that as a what? Ordered pair. So this is 2, negative 3. Let's check that in both of the equations, make sure it really works. You have 2 and negative 3, so you've got 10 plus a negative 6 is 4, so that top one works. And does 2 equal negative 12 plus 14? Yes, it does. So this is a good solution. That's the proper solution. This one was already set up for you, that x was already solved for. So look at b here. Why don't you go ahead and do b right now? What's the smartest variable to solve for? X or y, top or bottom? Bottom for y, you got it. There's a nice 1 in front. You're going to solve for y, so get rid of the 2x. And you've got y is equal to 4 plus 2x. You can write it either way, 2x plus 4 or 4 plus 2x, either way. Well, to answer this question, the easiest variable to solve for was y in the second equation. So you got this package here. What you're going to do is you're going to substitute that into the other equation. So you've got 3x plus 2y is equal to 1. We're going to substitute whatever y is, which we said is this here, 4 plus 2x. And here it is, 3x plus 8 plus 4x equals 1. And we're going to subtract 8 from both sides. 7x is equal to -7, so x is -1. Hey, once you get a concrete number, you can substitute in either equation. Wait a minute. This is where you think smart, not hard. You don't have to substitute in the top or bottom. Which one's the smartest one to substitute into? Yeah, the parentheses, the revised one. It was this one here. So it's the bottom one revised. So you've got y is equal to 4 plus 2x, but x is -1. And look at that, you crank the answer out in basically one step. Y equals 2. And as you said before, this is an ordered pair, -1, 2. Let's check, make sure it really works. Put -1 and 2 here. And you get -3 and +4 is 1, so that's correct. And +2 and +2 is +4. So it is the correct solution.